Atwood's machine. This video concerning Atwood's machine is very important to precise the direction of each system. As you see here, we have many examples, and for each one, the common object is a pulley. Maybe you have one or two pulleys for each system. And for each system, you have many objects. And each one takes a different direction of motion. Okay, let's say the first example here, example figure 1, we have m equal 5 kilogram. The motion will be on the table horizontally, and m equal 9 will move up or down. Okay, up or down, and m equal to 5 moves right or left. Here, to precise the direction, the positive and the negative for each one, first of all, I have to precise the line of motion. Let's say here we have clockwise motion. I mean, the system will move to the right. M1 will move to the right. In this case, M2 will move down. So this direction will be positive for each one. As you see here, we have two different positive direction. Okay, the opposite of this one will be the negative for each one. This is negative and negative. Okay, here you can say this positive and this negative represents the x-axis. You can say like this. Here we have x-axis and here y-axis. So like this is positive, the opposite is negative, up will be positive and down will be negative for this object. But for the second object, we said here down is positive, up is negative. We can draw also x-axis, but the positive must be down here with the same direction with the positive, the blue one. So like this is positive, the opposite will be negative, right is positive, and left is negative. Okay, you can say here in this case x and y as you like. For example, in this case, the positive, vertical positive, you can say here x or y, whatever. So we can say here y, and here we have y prime. And the x-axis or the horizontal axis will be x, and the opposite will be x prime. For the first one, the positive x-axis will be x, and like this you will have y. Okay, and you solve each one separately. Let's take another example, the second one. Here I don't know if the system will move to the right clockwise or anti-clockwise. We consider that the system moves clockwise. Okay, in this case, M1 moves up, M2 moves along the inclined plane. Okay, it's not vertically. So here we have the positive, and here we have the positive. The opposite must be negative for each one. Here we have a negative, and here we have a negative, the opposite sign, negative and negative. When you finish, you put X and Y to have or to do the projection after of the masses and the forces applied on each object. Let's say the object M2. You have the direction of the motion. You can say this one is X. I advise you to take X-axis always in the direction of motion, okay? And here you have Y. Y and X. Okay, so like this you have positive, the opposite is negative, up will be positive, and down is negative. Okay, we can take another example here. Okay, I will apply the same method. Here we have the system. Also, I consider that the system will move clockwise. This one moves up. So up, this one to the right, and m equal to 2 down. This one is a positive for each one. And we draw the opposite of each one must be negative. Okay, we can write like this. Okay, for each one we can do X and Y as before. Here we have X and Y, X and Y, X and Y. And it's important to say up is positive, down is negative, right is positive, left is negative. Okay? The same here, right positive, left negative, up positive, down negative. Here, up negative, down positive, right positive, left negative. Okay? And the same for this one, you can say we have clockwise motion. Up is positive, down here is positive, the line of motion. The opposite must be negative, negative, and here we have negative. We do X and Y, like this must be positive and the opposite negative, and the same here, X and Y. To the right must be positive, to the left must be negative. Okay, a very important point here. Maybe you don't know, we considered that we have a clockwise motion, but I am not sure. Maybe the system will move anti-clockwise motion. In this case, you calculate A, okay? If the value of the calculated value of A is positive, so you choose a right direction. If the value of A is negative, the calculated value, so the direction must be opposite in this case. You keep everything well, you don't change anything in your calculation, but you have to know that the direction will be opposite in this case. Okay, that's all about this. Let me, in the next videos, I do some application and we can discuss each case individually. Thank you.